Hello students, this is Mrs. Tran-Bloom. This is another video note. On this video notes, we will be going over Unit 5.1. I'm recording this with my daughter. We are homesick today, but before we record, she would like to tell you some jokes.
What do you call a bear at a wedding?
What?
A ring bear.
Yay! Good job, honey. Mwah. Okay.
What?
Do you have another joke or you're done?
I have another.
You have another joke?
Mm-hmm.
Oh.
What?
Where do fish keep their money?
Where do fish keep your money?
Where?
In the riverbank.
Oh my goodness. All right. Thank you for telling the jokes. Okay. So we will start with, as Stevie is watching pre-calculus. She is 6 years old. We will start with example 2, double I. Okay. There are 4 parts on 2 double I. So the first one we're going to do, this is the direction right here. See that right there? We are going to try to do all of them and see if I can fit on here. So A. I don't have my normal stylus with me, so I'm trying to write this stuff with a new stylus or with my finger and see how it goes, okay? All right, so A said F composed with, ooh, that's an ugly composition. Like I said, I'm writing this with a different stylus, so it looks really funny, okay? So F composed with G of 1. So what that means is, by definition, it's F of G of 1, okay? So when you're doing a composition, just like last time, you would have to do the inside first. So make sure the inner composition is done first before you try to do the other one. So this one, let's do G of 1. So G of 1. And when you're doing the composition, it's the same, okay? So you plug 1 in for G. So this gets 2 over 1 square, which is 1 plus 1 equals 2 on the denominator. So 2 over 2 equals 1. What's 2 divided by 2, Stevie? 1. Okay, so now that we have this piece now is 1. See that right there? So the next piece is you are now going to compose the outer piece, which is the F, okay, of this same value. So now let's do F of 1. And not always that they come out to be 1, okay? So make sure you understand that piece. F is an absolute value function. So absolute value of 1 minus 3. Well, 1 minus 3 inside an absolute value is negative 2. Absolute value of negative 2 is 2. So your entire composition comes out to be 2. Oh, thank you. All right, let's do B. We have a lot to do, okay? So B said we're going to do the same thing, but this time is reverse. So I would like to do G composed with F of 1, and again, by definition, is G of F of 1. So the first part we will try to do, oops, I meant to move up, so let me erase that. Okay, so we're going to try to do is, let me try to move up really quickly because it's getting, oopsie, there you go. There you go. Okay, so the first part we're trying to do is F of 1, okay?
You kind of erased it, the G, Mommy.
Yeah, I erased it a little bit.
It's okay. You guys know that's a G, right?
So F of 1, that means we're going to do, we will plug in 1 for my assistant here. We will plug in 1 for our F function. So 1 minus 3, just like earlier, it's an absolute value of a negative 2.
What does plug in 1 mean?
So we're going to get 2. So now we will do G of 2. So G of 2, okay, equals 2 divided by 2 squared is 4. 4 plus 1 is 5. So our answer for this second part is 2 over 5. Box that up. Since I write super big, I'm kind of running out of space. So what we would try to do is maybe, oh, I keep doing that, don't I? Maybe just put C and D over here, okay? We'll put C over here. C, as you noticed earlier, it's going to be, let's move up a little bit here.
Not the marker.
Yep, you're right. I need to activate. Hold on, guys. I need to move up and down. And I'm on a different laptop, so I'm not familiar with what's going on.
Because it's Daddy's laptop.
Yeah, it is. All right, let's try this out again. There you go. All right, so C, let's see what C is asking us. Okay, C is asking us to do f of f. Okay, so f of 2. So f of 2. All right, so by definition, this is f composed with f of 2. So yes, it's exactly the same thing. In this case, you're just doing f of 2 twice. Okay, so let's do f of 2. You're going to do absolute value 2 minus 3, which is a -1. Absolute value of -1 is going to be +1. And then now you're composing f of 1 again, which seems like we've done a lot of these. Okay, f of 1. So f of 1 is going to be absolute 1 minus 3, which is going to be a +2 because of an absolute value. So f composed with f of 2 is 2. All right, we're now on the last one, which I would like for you to do on your own. Okay, so this is sort of your check for understanding. Take a couple minutes, do a little pause for me, and do that all on your own, please. Once you're done, then you can hit play again so you can listen to the next one. Okay. All right, we'll move down here quite a bit. Now that you are done with D, let's continue with example 3.
Yahoo, you're done with your first homework.
Example 3, find the following and state the domain of each composite. Okay, so this one's a bit more difficult. So make sure you
difficult.
make sure you pay attention and rewind and rewatch if something didn't really click. Okay, so A, F composed with G. Okay, you're doing a composition, but this time it's not a constant value. This time you're composing two functions together. So what you're doing by definition is f of g, but the input for g is x. So this is really f of g of x. Well, you know what g equation is. G equation is just simply this, okay? So what we're going to do is we're going to plug in f. Your input's no longer just an x value for f. The input for f now is 4x plus 1. And I do apologize for this funny writing. I feel like I'm in kindergarten. Okay, so that means every time you see an x, an input,
Really, it looks like preschool writing.
Every time you see an x in your f of x, you are now replacing this with this, okay? Okay, but before we go, because the direction sets state the domain of each composite. The domain of each composite is involved two different places. It's at the beginning, which is here, okay? And then at the end. So look at the input. This is a line, so this domain is going to be all real numbers, okay? Remember, the only time that you exclude values is when you have a fractions or a radical. If you don't have a fractions or a radical, the domain of the polynomial is always all real. Okay, so now that we stated the domain of the beginning, we are now going to compose. So f of, oops, I don't want to do that anymore. I already did that. Okay, so here we go. F of 4x plus 1. I see a 2. That's not an x. I see an x square right here. See this right here? Okay, and it's an x right there. So I'm going to replace those two x's with 4x plus 1. So 4x plus 1 and square it. Okay, and then minus, I see another x. Don't forget, if you're going to subtract a polynomial, you're going to need a set of quantities. Okay, a set of parentheses. So 4x plus 1 and bring down my positive 4. And from here, we will distribute. So instead of just doing it in my head, I'm just going to write this out twice. 4x plus 1 times 4x plus 1. That's what a square power means. And then distribute the negative. So this is going to be a minus 4 minus 1, bring down my positive 4. Then from here, I'm going to distribute the 4x plus 4 twice first. So that's 16x squared. And in the middle, you have 4x times 1, and then 4x times 1 again. So that's positive 8x. and then 1 times 1, the two end numbers, so it'll be positive 1. A minus 4 and a positive 4, that would cancel, and now I have a negative 1 back here. I'm going to distribute my 2, so this is 32, okay, x squared plus 16x plus 2 minus 1. And I'm almost done with adding and subtracting. So from here, I just have a 32x squared plus 16x, a positive 2, and a negative 1 is going to be a positive 1. And this is what you get, okay, for composing. This is what you get for composing those together. Now, it did want you to state the domain. Now, this is a polynomial without any fractions or radical. So the domain of this is going to be all reals, okay? And because this is all real and the beginning domain is all real, we don't need to exclude anything at all. You would need to exclude values if the domain in the beginning is not all real. So make sure we get to some of those examples, okay? All right. What I would like to do next is I'm going to let you or ask you to do composition B and C, okay, on your own, which I have a lot of space here.
Yoo-hoo! Get it, Polly!
Hold on, honey. I'm gonna make sure I'm not invading this space because I give you plenty of space down here. So what I would like for you to do is take some time, okay, do B right here, okay, then take some more time and do C underneath it, and what I'm going to do is I'm just going to do D at the very bottom, okay? So let's say we will put B right here. You can probably write a lot smaller than my, oops, I meant C right here. So check for understanding is your B and your C. And then I will do D at the very bottom. Okay, so so I'm going to do D right here. So either you pause and try to do B and C right away and then unpause to do D, or just listen to my D, which is a composition of F composed with F. I'm sorry, not F composed with G composed with G, and then go back and do B and C. Okay, so here we go. G composed with G, it's D. All right, G composed with G, so by definition is G of X. Okay, let's see what G equation was. I kind of forgot. What is the G equation? Let me go back up. G equation is 4x plus 1. Actually, that's an easy one, huh? How about I'll let you do that one on your own, and I'll do, looks like the F composed with F is more difficult, okay? So let me do F composed with F. Let's do C, because D is a little bit more easy. It's a little easier. Okay, let's do F composed with F. And F function is 2x squared minus x plus 4. Okay, so let's do letter C. So F composed with F, oops, that doesn't look like an F at all. That's actually G. Okay. F composed with F. So by definition is
Mommy?
F. Yep.
Do you guys only do math?
We only do math. This is a math class, honey. Okay. So f of x is, let's see what f of x is. I think I said 2x squared minus x. And then what was the last one? Let's go back and look. 2x squared minus x plus 4. Okay. All right. Okay. So this one, the reason I'm doing this one instead of D is that way this is a little bit more difficult. D is easier, so I'm gonna ask you to do example C and D on your own. Okay. So every time I see an X in F, okay, this is now your new input. So I just want to make sure you understand. Okay, this is now your input. So there are two X places in F. One spot here, okay, and then one spot here. So you're going to replace this yellow polynomial in two different places. So that means, here we go, I have a 2. That's not a variable. I have an x squared. So at some point, I'm going to have to substitute that with 2x squared minus x plus 4. And then this is a minus, not a plus. Okay, this is a minus. And then there's another x, so that's where the polynomial is going to go, and bring down your 4. So let's write it in. Here we go. Let's try to get a yellow marker just so that you can see it. Okay, this gets 2x squared minus x plus 4. And because the power is square, so you're going to square that out in a little bit. And because you are subtracting, so that's why you need parentheses. And that go in there twice. 2x squared minus x plus 4. And the reason you're writing it twice is because there are two x variables for this f function. Okay. All right, so now let's distribute. You're going to have to be very careful with distribution. I'm going to write this out twice so you guys can see where, oops, plus 4. There you go. So you guys can see where or how I am multiplying it. Minus x plus 4. I'm now going to distribute my negative sign, so that's going to be negative 2x squared plus x minus 4. Bring down your positive 4. And from here, slowly, I'm just going to erase this d piece really quick because you guys have enough space. I just don't because writing is so big. Bring down my 2. So here we go. 2x squared times 2x squared is going to be 4x to the 4th. Okay, so that's 4x to the 4th. 2x squared times negative x is going to be a negative 2x to the 3rd. 2x squared times a positive 4 is going to be positive 8x squared. All right. In the middle, okay, negative x times 2x squared is going to be a negative 2x to the 3rd. Negative 2x to the 3rd.
Mommy,
Yes, honey?
this one is harder.
It is. Negative x times negative x is going to be, oops, negative x times a negative x is going to be positive x squared. So positive x squared. Okay, so just carefully multiplying this out. Then you have a negative x times positive 4 is going to be a negative 4x. I'm writing them one on top of another so that way I can combine like terms in a little bit. Okay. Then last term, 4 times 2x squared is going to be positive 4x squared. I'm sorry, 4 times 2x squared. See, I can't multiply. You guys all know that I can't divide. Now I can't multiply. So positive 8x squared. Then 4 times negative x is negative 4x. And then last piece, 4 times 4 is now a positive 16. Okay. Then I'm just going to bring down these over here. So bring down my minus 2x squared, bring down my, sorry, that's supposed to be a square looking thing, plus x. Oops, I said x and I wrote 4. Oh, look at that. Okay, plus x. Okay. Well, these two things will cancel one another out. Okay. So now let's just combine like terms over here. So this is 2 is still in the front. Bring down my 4x to the 4th because that's the only thing. Negative 2x to the 3rd, and another one is going to be negative 4x to the 3rd. Sorry, this writing is awful, isn't it? Okay.
No, it isn't.
It isn't? Okay, so this is going to give me 16, 8x squared plus 8x squared, 16x squared. There's an x squared in the middle, so positive 17x squared. Bring down the 2, okay, and then minus 8x. Bring down the 16. And then bring down my 2x squared plus x. Okay, I feel like I'm going to do a better job with my finger. Let's try that.
Wait,
okay.
you're gonna erase all of that, Mommy?
I'm going to not erase, but I'm going to use my fingers now. Okay, so now 2 times 8, 4x to the 4th is now 8x to the 4th. That's better. I think this was supposed to be a 4 right there. So 2 times negative 4 is negative 8x to the 3rd. And then 2 times 17 is a positive 34x squared. 2 times negative 8 is a negative 16x. Bring down the 16 times 2 is 32. And bring down the minus 2x squared plus x. Let's combine some more like terms. These two can add and subtract. These two can combine. So our final answer is 8x to the 4th minus 8x to the 3rd. 34 and a negative 2 is now a positive 32x squared. A negative 16 and a positive x is now a negative 15x plus 32. Okay. Whew! My goodness. Okay. That was a long one. A long multiplication one. Okay, so what I forgot to do was I forgot to identify the domain at the beginning. So I want to make sure because we have to state the domain. Okay, so this is a polynomial. So the domain of this is going to be all real. Looks like I can do a better job with my finger. Then that brings me, because it's all real, that means I don't have to exclude anything. Okay, so that means I'm going to need to go down here and check out my answer. Hopefully I multiplied this out correctly. Okay, if not, I'm pretty sure you'll let me know. Okay, so here's my answer. This is a polynomial as well. Because it's a polynomial, my domain for my final answer is all reals. So when you're writing the domain, you only have to write this piece. Oops, I meant to not do that. That was awful. Let me erase. I meant to highlight it. Okay, let's try the domain again. So the domain of this answer is all real numbers, okay? All right, but when you are writing the domain class, this is the only one you need to worry about. You don't need to worry about the initial domain, okay? That's just to double check whether we need to exclude anything. All right, y'all, this is the end of our notes, okay, for this video. But make sure you go back and do the check for understanding for
We love you, Daddy.
for B, check for understanding for go back and do D, because remember I said that was easier for you guys. So here's D that you need to do.
We love you, Daddy.
And there's one more check for understanding. Let me go all the way back up here for us to identify. Okay, and then there's one more check for understanding right here. So you have 3 problems that I would like for you to try it out on your own. All right, say goodbye, Stevie.
Bye.
Until next time, class.